Welcome. In this video, we will take a look at the introduction to limits through the definition and a few diagrams. So first to the definition. The two-sided limit as x goes to a of f is L if the value of f of x gets closer to L as x gets closer to a from both sides. So notice that when we use this arrow, this really means as x gets closer to a or approaches a. So in our diagram, let's consider this x value getting closer to this point a. As we approach our function from both the left and the right, we notice that as x approaches a, the functional value is approaching L. This is what we mean by a limit. Notationally, we would say this is represented with the notation limit as x goes to a of the function f of x is equal to L, where this L is some y value that the function is approaching. Notice that this limit concept is not thinking of or asking the question of where the function is defined. So we are not concerned that the function is defined at this value a. It could have a functional value or it could have a hole in the graph. We don't really care as long as it's approaching one value. So fundamentally, limits are different than the idea of a functional value, and we want to keep those two concepts separate. If we take a look at the example here with the red graph of f of x, let's consider the two limits at 2 and 4. First, we can say, what is the limit as x goes to 2 of the f of x function? This would say, as I approach from both the left and the right side of 2, what is the function converging or going to? Well, taking a look at our diagram, as we come to the left, we're coming up to this open circle at y equals 2. And as we come from the right side, we are approaching again that open circle at y equals 2. So we can say that the limit as x goes to 2 of the f of x function is equal to 2, where that 2 is represented by that functional value or that y value. Notice that this is not a defined functional value on the f function, but it still can represent a limit solution. The second limit that we could see to take is the limit as x goes to 4 of the f of x function. Notice that this is a defined point on our graph. As x approaches 4 from both sides, notice that we are approaching this functional value y equals 3. So we can say that the limit as x goes to 4 is going to be equal to 3. Now, taking a look at the idea of the functional values, we can see that the functional values are asking a different question. We could ask, what is the functional value at 2? The functional value at 2 for f, well, that's a hole in our graph, so that would be undefined. But for x equals 4, we could say that x equals 4 would produce the functional value at 3. So sometimes the limit values are equal to the functional values, but sometimes they are not. So again, we want to think about these two concepts separately. Sometimes they happen to be the same, but in general, they are not the same.